looks like I had to divide that one into two parts because the next one is line 18u2. Okay, so this is part 212. Line 18u2, this is a continuation of the last video, so you want to start with line 18u first. Watch that one first and then watch this one, okay? So this is line 18u2 Chandra X Ray Spectra Geminga EXOSAT Gamma Rays Wow Seti. There's the alien signal there. My thoughts, I posted some photos exactly like these last night around 2 a.m. EST. And I didn't know what they were, and now I'm finding out what X Ray Spectra means. January 28, 2012. Awesome. So ModPython. It's an Apache module that embeds the Python interpreter within the server. With ModPython, you can write web-based applications in Python that will run many times faster than traditional CGI and will have access to advanced features such as ability to retain database connections and other data between hits and access to Apache internals. So that's www.ohloh.net. So I googled Chandra X Ray Spectra and read it, Chandra X Ray Observatory NASA Science Photo Library. Caption is black hole spectrum, colored Chandra telescope X-ray spectrum of the black hole binary system XTE J1118 plus 480. The spectrum narrow line top left to bottom right shows the X-ray energies emitted by the system. The highest energy emissions are nearest to the center of the spectrum. This system is thought to be composed of a sun-like star orbiting a black hole, a star that has collapsed under its own gravity. The spectrum was measured by Chandra's Low Energy X-ray Transmission Grating LETG, which collects the system's X-rays and then changes their direction by different amounts according to their energies. So the next thing is that Google Chandra's Low Energy X-ray Transmission Grating LETG from www.sciencephoto.com. And I get the LETG Chandra X-ray Observatory from Harvard EDU. The Low Energy Transmission Grating LTG was developed under the high resolution X-ray spectra of optically thin plasmas. So again, the word plasma comes up. The Low Energy Transmission Grating LTG was developed under the direction of Dr. A.C. Brinkman in the Laboratory for Space Research, SRON, in Utrecht, the Netherlands, in collaboration with MP for Extraterrestrial Physik MP in Garching, Germany. The grating was manufactured in collaboration with Heidenheim GmbH. The Low Energy Transmission Grating Spectrometer, LETGS, comprises the LETG, a focal plane imaging detector, and the high resolution mirror assembly discussed in Chapter 4. That's askascharvard.edu. 9.11 Scientific Objectives. The LETGS provides the highest spectral resolving power, greater than 1000 on Chandra at low energies, high-resolution X-ray spectra of optically thin plasmas with temperatures between 10.5 and 10.7 K. Such as stellar coronae reveal a wealth of emission lines that provide diagnostics of temperature, density, velocity, ionization state, and elemental abundances and allow precise studies of structure, energy balance, and heating rates. So I Google Einstein and EXOSAT, and it says the Invisible Sky, Rosat in the Age of X-ray Astronomy. It's a Google book from, can't say that name, Ashlyn Blanche, Herman Michael Hahn, and Joachim Trumper, 1998. Einstein and EXOSAT, in spite of singular success of balloon-borne X-ray astronomy, a more complete investigation of the invisible sky remained the domain of. Next thing that came up was Extreme Ultraviolet Astronomy from Martin Adrian Barstow and J.B. Holberg, 2003. Selected scientific results from Einstein and EXOSAT, although the Einstein and EXOSAT observatories were primarily X-ray astronomy missions. Your next thing that comes up is comparison of Einstein and EXOSAT. Let's see. This from D.L. Band, 1989. Then Einstein and EXOSAT observations of Geminga. Fix this before I forget. There's that. Summary of short, medium term violet. Okay, I don't know what all this is. A bunch of stuff that came up here. So the X-ray source was discovered by me on 19th during an X-ray survey. The survey was conducted with the aid of Einstein Observatory. The involved field was observed with the EXOSAT satellite in September 1983 when both low-energy telescopes were still operating. The Einstein and EXOSAT databases were utilized in analysis. Evidence for periodicity was found in both the Einstein and EXOSAT data. The EXOSAT CMA1 and CMA2 fields are shown together with the Einstein IPC and HRI data. Okay, so they're talking about a bunch of stuff. I don't know what they're talking about. So Google Geminga source. Geminga was the first example of an unidentified gamma ray source, a source which could not be associated with any objects known at other wavelengths. So there's one there. Okay, excess positrons are linked to Geminga pulsar. Geminga is the nearest known gamma ray source. Dark matter particles are expected to collide with one another and annihilate, producing high-energy particles such as electrons and positrons. If these particles could be observed, they would represent the most direct evidence yet for the existence of dark matter. Okay. Then there's the Pamela satellite. In particular, in 2008, researchers working on the Pamela satellite found an excess of positrons from 10 to 100 GeV in the cosmic ray spectrum. The results could not be explained by standard models of cosmic ray origin and propagation in the Milky Way, and instead suggested a nearby source of high-energy positrons. However, there has been no conclusive evidence linking the positrons to dark matter, and the annihilation rate is far higher than expected from standard theories. Now, Hassan Yuskil and Tokdor Steknev at the University of Delaware and Matthew Kistler at Ohio State University claim that the source of these positrons is Geminga, a nearby and rapidly rotating neutron star. The results also represent the first time that astronomers can link cosmic rays to a specific source. At the heart of their theory is seemingly unrelated set of observations by the Milagro Gamma Ray Observatory in New Mexico, which has seen a halo of high-energy gamma ray sources around Geminga. Located approximately 800 light-years away from Earth and some 300,000 years old, Geminga is the nearest known gamma ray source to Earth, excluding solar system bodies. So the Pamela positron exos, physicsworld.com. So I Googled that. So now the Pamela result has been confirmed by a acute measurement performed by the Fermi satellite. And there it shows. Blocked white, allowed from west, blocked white, while allowed from east, preliminary heat. The black data points are from Pamela, and the gray band is the Fermi measurement. With their systematical uncertainties, the two are nicely consistent, so we don't know whether the positron excess is due to dark matter or pulsars or old newspapers, but at least we know for sure it is real. There's another graph there. The point is that for certain hypotheses, like for light dark matter, and annihilating into tau leptons or B quarks, they are already excluding the cross sections expected if the dark matter is a thermal relic. So they're really closing in on the parameter space where a signal may be lurking if the WIMP paradigm is true. No luck so far, but they'll try again next year. So that's resonances.blogspot.com. Fermi Gamma Ray Space Telescope confirms puzzling preponderance of positrons. So there's a graph there. So this illustration shows an example of the Earth's geomagnetic field and the Earth's shadow blocking particles of one charge while allowing oppositely charged particles. By finding a clever way to use the Earth itself as a scientific instrument, members of SLAC-led research team turned the Fermi Gamma Ray Space Telescope into a positron detector and confirmed a startling discovery from 2009 that found an excess of these antimatter particles in cosmic rays as a possible sign of dark matter. That earlier discovery by an instrument called Pamela has set off a burst of speculation. Did the extra positrons, the antimatter mates of electrons, come from an astrophysical source such as a pulsar, or from a more exotic origin, the annihilation of dark matter particles? Both sources have their proponents. Pulsars are maelstroms of magnetic forces that are still not easily understood, and while dark matter particles are slippery customers, through gravity dark matter has had a big effect, shaping galaxies and influencing the structure of the universe. and that's news.slack.stanford.edu. Measurement of separate cosmic ray electron and positron spectra with the Fermi Large Area Telescope. And these are all the doctors that work on that project. There's tons of them, tons. September 2011. So we measured separate cosmic ray electron and positron spectra with the Fermi Large Area Telescope. Because the instrument does not have an onboard magnet, we distinguish the two species by exploiting the Earth's shadow, which is offset in opposite directions for opposite charges due to the Earth's magnetic field. We estimate and subtract the cosmic ray proton background using two different methods that produce consistent results. We report the electron-only spectrum. The positron-only spectrum in the positron fraction between 20 GeV and 200 GeV. We confirm that the fraction rises with energy in the 20 to 100 GeV range and determine for the first time that it continues to rise between 100 and 200 GeV. Okay. So January 29, 2012, my thoughts. Emailed Justin to let him know his data comes up in line 18, and asked if they could look at the data about neutrinos, relativistic jets, thermal radiation files on Wow Seti signal, the idea girl. Okay, so there's a gamma ray picture. There's some more graphs and stuff there from the CERN Courier. There's more stuff there. I'm not posting all the diagrams or on the website. I'm only pulling the data that have the same words that came up in the Wow Seti signal. Okay. So I don't know what this data means. Okay, so you can go look at their site, www.gamma-armenia.org, and you'll find it there, okay? The other one's Gamma Armenia, yeah, from the CERN Courier. That's all the stuff for that video, okay?